NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
A two-in-one shot at Cape Kennedy. Pioneer 8, a spacecraft to orbit the Sun, and a small test and training satellite, now providing tracking and communications practice to stations of the Apollo network. The pair of space travelers were recently launched piggyback style, with Pioneer 8 the main payload. As part of its scientific mission, the spacecraft will help predict when large, highly radioactive solar flares are about to explode on the Sun, so that manned flights may be scheduled around them. At NASA's Ames Research Center in California, Pioneer Project Manager Charles F. Hall gives a status report.
Pioneer 8 now joins its two successful predecessors, Pioneer 6 and 7, in exploring solar phenomena at widely different locations in interplanetary space and at distances up to about 200 million miles from Earth. All three spacecraft are transmitting measurements of cosmic rays, plasma, and magnetic fields to Earth. These data are then sent to this center where they are analyzed by the scientists. Based upon this analysis, it is expected that we will have a better understanding of solar phenomena and its effect on the environment near Earth.
High-flying pioneers, giving scientists the broadest picture yet of conditions in interplanetary space. These divers are following the sound of a small underwater device attached to a rocket section at the ocean's bottom. The constant pinging sound guides the recovery team through the darkness to the exact location of the submerged section. Research and development of underwater location aids like this offer more than one use. In addition to expediting the recovery of rocket and spacecraft parts for analysis, strategically placed devices on aircraft could help recover planes downed in water. Studies began 3 years ago at NASA's Langley Research Center in Virginia with a Navy-developed locator used in mines. But to be of real value in space, the location device had to be miniaturized, scaled down from its original weight of 3 pounds. Paperwork designs were made, studied, modified, and redesigned. The end product, a self-contained 12-ounce cylinder, 3 3/4 inches long. At the Navy's Underwater Sound Lab, output tests showed that the pinging sound could be heard for more than 4,000 yards. Next, more realistic tests. An aircraft crash recorder with the tiny transmitter attached was dropped from a helicopter at an altitude of 5,000 feet, simulating the impact of a crashed airplane. Armed only with receivers and the coordinates of the 100-square-mile impact area, the recovery team moved in for the search. Approximately every 2,000 yards, the boat would stop. The receiver was then placed in the water and turned a complete circle in an attempt to pick up the signal. When no signal was heard, the boat moved ahead another 2,000 yards, assuring an overlap of the search pattern. With this method, the entire 100-square-mile area could be covered in 2 hours. The procedure was repeated until contact was made. Then, using the receiver to guide them, divers made the final search and retrieval. Underwater recovery devices, making it possible to reduce search time to a minimum.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.